Hello, good morning from me too. I'm Elena Rokou, the Chief Research Officer of Creative Decision Foundation, and let me take you to decision making for leaders. So, starting, how's the weather today? Are you feeling cold? Warm? The temperature over here this morning was around 59 Fahrenheit. I'm half Greek, half Italian, and when I first moved here in Pittsburgh, it was super cold. I think that I needed 2 jackets and a sweater to go out on 59 Fahrenheit. However, for most of us, it's perceived as cool. That's to show that numbers can be deceptive, sometimes at least. We want our decisions to incorporate the numbers, but as our perception of the value of the numbers to us, we want to use our experience and knowledge when we make decisions. We want even to include our gut feeling in the mix while also being precise in using the measurements. What is AHP and ANP? AHP and ANP is a family of methods that allow us to make decisions by combining tangible and intangible factors. You can reduce complex decisions to a series of one-to-one comparisons that are easier to tackle. This way, the decision maker can end up with the best decision for the problem at hand, taking into consideration who is deciding and what is their perspective. On top of that, you will have a clear rationale about how you ended up with this decision. How can I use the AHP and ANP methods? Well, you can use them to select the best alternative, predict likely outcomes, facilitate group decision-making, even conflict resolution, resource allocation, obviously prioritize risks, and manage portfolio, but even more. In situations that we have very hard problems at hand, we can do a benefits, opportunities, cost and risks analysis, which is something similar to the SWOT analysis that you are probably very familiar with. Does anybody use AHP today? Well, let's see some of the organizations using AHP and ANP, starting from over here, Federal Aviation Administration, United States Department of Agriculture, or even the Texas Transportation Department, that they are doing amazing stuff with AHP. And we can get to the other side of the world, and even People's Bank of China, Defense Health Agency, China Geological Survey. So why do they use them, or how do you use this kind of methods? Let's see some of the examples of how you can use AHP and ANP in your business. You can use it to do a resource allocation, and that's probably the most common way of using AHP, or a supplier selection. Or you can use it for strategic decisions, like Kraft and Heinz were deciding whether they should keep 2 different headquarters or merge everything in one city. Or new product development decisions, like should Body Armor invest in a new product, protein recovery drink, or not? What should we do post-pandemic? What kind of work schedule should we adopt? Should we have hybrid? Should we have work from home only? Should we go back to our offices as we used to do pre-pandemic? What should be the approach? And the results really depend on the company and the situation and the kind of jobs that they need to handle. Or even, remember that period of time that Amazon was not able to fulfill their Amazon Prime goal and send the products on time because it was the beginning of the COVID situation? Well, that raised a lot of problems with their customer satisfaction levels, and they were considering different ways of working through the problem. AHP and ANP is a good way of deciding this kind of situations. But why? Well, let's see in our decision-making situation in a very specific model. Let's assume that we have a small manufacturing company that uses flexible manufacturing cells, FMCs, to produce 3 products, A, B, and C. An FMC is a group of computer control machines interconnected by material handling system that really facilitates the production of different items by the same machines. Each product requires different steps and processing times on different machines. You see over here a very short simulation of how the products go through the different machines. You need different times in each machine, even different order, and you see also the operators that are handling the machines and facilitating the whole operation. The simulation gave us back some results referring to the processing time that we require, the way that the actual time in system for each of these products. And what we are really wondering, well, let's see. First of all, we have seen that the competition has started producing a new product, D. The demand for this product is expected to be very high the next 3 years. On the other hand, our production manager is concerned because product B demand has been unusually low the last quarter. We are already producing ABC, and we are evaluating whether we should change the product mix or add product D to the production mix. What do we actually know about these products? Well, we know from our simulation and the collection of data, processing times, minimum, maximum, average, mean, all that information. We know the expected profit per unit and the timing system. So for example, product D, the one that we are considering to add, has a pretty high profit, $22 compared to the rest. Only product A is close to that, and expected high demand. On the other hand, the timing system is also high. That's what we saw in our simulations, and also the processing time is probably the highest within the mix. So the question, which 3 products should we produce? We had a meeting with all the concerned parties, and we are trying to define what are the decision factors that we should consider in this decision. After some brainstorming, we ended up with the following decision factors. On one hand, I have some quantifiable numbers, profitability, processing time, expected time, and system. On the other hand, I have some intangible factors that I want to consider. Demand, expected demand, really, fit with the other products that I am already producing in this factory, and even alignment to the company's goals. How are we going to combine the tangible and intangible factors to make a rational decision? Well, that's what we are here to see. How does this AHP and ANP method work? Well, we need to define the problem to solve, identify the possible solutions, and you see, we already defined the problem. My problem is how I'm going to define the product mix, and my possible solutions is some combination of A, B, C, D. Define the decision factors. We have 6 decision factors in this problem, 3 tangible and 3 intangible. Group the decision factors. When you have more than this, probably you will need to do grouping, and sometimes you will need even to break down factors, decision factors, to sub-factors and go deeper and deeper in your analysis, and then find the flow of influence. What do we do next? We pairwise compare the factors in the alternatives, and we calculate the results. Well, how do we calculate the results? How do we do the pairwise comparisons? Let's see with a very, very, very simple AHP example. Let's assume that what we are trying to do is to define the size of 3 apples. These are the 3 apples that I was given, A, B, and C. Probably the simplest AHP model that I can give you. My goal to define the size, and that's my only criterion as well, the size. My alternatives, apple A, B, and C. How will I end up to the results without measuring, weighting, or doing anything to these 3 apples? Well, just by asking the right question at the right time. With respect to size, which apple is larger, A or B? I say A. By how much more? I think that A is twice as big as B. What about A versus C? I estimate that is 6 times larger. What about B versus C? Well, I think that is 3 times larger than C. That's all. These are the 3 questions that I need to answer in order to get. Well, let's go back one step. A pairwise comparison matrix has the same lines and columns, which are the items that you are pairwise comparing. The diagonal has ones to show that when you compare something to itself, it's equally important, equally big. The ratio is 1, really. In this pairwise comparison matrix, like in all pairwise comparison matrices, we have reciprocals. So if I put for A, B 2, then B versus A doesn't need to be requested by the decision maker. I will know that it's reciprocal. So it's 1 over 2. Similarly, if A over C is 6, then the reciprocal will be 1 over 6, and I will not be asking a question about that. So this way, I need to ask questions, pairwise comparisons really, only for the items that are on the upper triangular of my matrix. How do I get a quick estimation of the results? It's not the real result, but it's a really close one. I add up the lines, and then I divide each entry by the total sum of my items. This way, I'll get my normalized priority vector, my normalized result. And if I want to focus or spotlight the best option, or even remove any factors related to the number of items that are in that list, I'll use the idealized view. What is that idealized view? I'll have to divide each entry from the normalized factor by the maximum entry. That way, I'll see the value 1 that corresponds to the best solution, and everything below that will be something less than 1. All right, enough with our small problem. It gave us an idea. But what about the situation that I make mistakes? What if I don't say that B is 3 times larger than C? What if I say that it's 4 times or 5 times? Well, the farther we are from the true value, the more inconsistent we are. We calculate this inconsistency of an entry by replacing that entry and its reciprocal with 0 and recalculating the priority vector. Then we will compare the initial priority vector with the new one. AHP provides a theory for checking the inconsistency throughout the matrix and allowing a certain level, usually up to 10%, of overall inconsistency, but not more. What about the numbers that I was using? There are verbal expressions for making pairwise comparison judgments. We are talking that 1 is used for equal importance, 5 would be strong or essential importance, while 9 would be extreme importance. You can use the intermediate values 2, 4, 6, 8. You can even use decimals whenever needed, especially when we are doing calculations to derive those judgments. And of course, as you notice, we use reciprocals for inverse comparisons. So if I want to say that B is not larger than A, but smaller, then I'll say that B is 1 over 2A. That means read it the other way around. A is twice as big as B, or B is 1/2 of A. And that's how we use the reciprocals to inverse the comparisons. Going back to our model, I have a goal to define what's the best product mix. And I have my criteria: demand, profit, fit, process time, alignment, and time in system. In an AHP model, you will always connect the goal to all the criteria, and each criterion that resides at the bottom level, now here we have everything at the same level, will connect them to the alternatives. This is my basic structure. Now, if I have criteria and sub-criteria, I'm going to connect the parent criteria to the sub-criteria, and then the sub-criteria are the ones that will be connected to the alternatives. Now, in our case, what I'm trying to do with this first set of pairwise comparisons, well, the question is, with respect to my goal, that is to optimize the production mix, what is more important, the demand of the product or the profit that it brings? And I'm answering there, one, they are equally important to me. And you can say something different. And at another point of time, I might say something different. And that's okay. That's why we keep the structure pretty much the same, but we evaluate the judgments from time to time to make sure that they reflect the current situation, both internally and externally. Because as the environmental variables change, the judgments that you will enter in the model will change as well. Demand versus fit. Oh, I think that it's more important for my company, demand versus fit. Actually, I think that demand is 3 times more important than fit. And I go on and I pairwise compare all these decision factors. And for example, I'll arrive at the point that you ask me, what is more important, process time or alignment? And I'll tell you, process time is not more important for me. Alignment is more important. And actually, I think that alignment is twice more important than process time. And you see the reciprocal over here. Alignment is twice more important than process time. When I'm done and I have entered all my judgments, making sure that my inconsistency is less than 10%. And when we are using tools like super decisions or even in Excel, we can calculate the inconsistency and find out if it's within the desired level. We do the same approximation or more detailed calculations, and we find the priorities of our criteria. We will find out that based on these judgments that I entered, profit is the most important criterion, followed by demand. Fit and alignment are quite important, while in the current situation, process time and timing system don't seem to bother me a lot. Now, for each of the criteria that I have, I will need to pairwise compare the alternative solutions, so my products. With respect to process time, what is better, product A, B, C, or D? Well, all these 3 criteria that I have here, process time, timing system, and profit, are tangibles. And from my simulation, I have actual values. That means that it would be perfectly fine to enter the profit values over here and find out that the most profitable one is product D, followed by product A and B, while C, it's really not bringing profit. On the other hand, if we go to the process time, we'll notice that just by entering the values, we are not getting the right results. The reason is because the longer it stays in the system and gets processed, the least good is for my calculations. So I want to invert those values. Process time is something that I don't want to appear in large quantities. I want small processing times for each of the products. After inverting, I'll get exactly what I want. That product C has the largest priority because it has the shortest amount of required processing time, followed by product A, and B and D are pretty much the same. Now, whenever you have numbers, you have to make a decision whether you will decide to enter the actual numbers or you will go and work on the way that you perceive those values. For example, I could tell you that 2 hours are not very important. So product B and D are actually pretty much equal. Or I could, in other situations, say that those 2 hours are really important. So the difference that I see here is just as 1% is actually perceived as a larger difference. What do I do in that case? I'll just go and use the pairwise comparisons in order to tweak a little bit my results so they reflect the actual situation, the way that I perceive those numbers and not just the numbers themselves. Timing system, similar situation, but now I'll have to also invert and find out that product C will stay for the least amount of time in the system, as before with the process time. I was kind of expecting it, and that means that it's the best option from that perspective. how do we work in the case of the intangible criteria? Well, in case of intangible criteria, we will go and do the pairwise comparisons. That's the only way that we can go, I guess. For example, with respect to demand, which one is expected to have a higher demand, A or B? Definitely A, 3 times more than B. B or C? That's the inverse. C is the one that I'm expecting to have higher demand, 3 times more than B. B or D? Definitely D, 9 times more than B. Same way, I enter the judgments and I make the calculations with respect to fit and alignment, ending up to find that product D provides more demand, followed by products A and C. Fit for product A is the best. It's the oldest product. I was kind of expecting to see something like that, followed by product B and C, while product D doesn't fit very well. It's the new, we haven't added it. We haven't really updated our processes to accommodate the operations required to produce product D. And the same goes with alignment. Product A is really representing the core values of the company. Products B and C were added in a second time. They are close to the company. They have been internalized. However, product D is going to push the company to a new direction. So it's completely different with respect to the other two. And if I combine my results to the initial priority vector that I got for the criteria, I'll end up that my product mix should have, if we are going to produce 2 products, A and D, in a ratio of 48-52%, or if we are planning to keep 3 products in the production line, then the best choice will be D, A, and C with the corresponding ratios. Is the solution robust? What will happen if instead of 3, I say 4? I mean, you know, some days you give a little bit larger numbers when you evaluate some stuff, and some days you use smaller numbers just because. What will happen? Will it change my results? Will it really affect what I'm going to get? Is this a method that is actually affected from how I woke up in the morning and what numbers I'm using? No. As long as you're consistent with yourself, you will always get the right results. But let's see what the sensitivity analysis says. On one hand, over here on the top of the screen, you can see the actual priorities of my 6 criteria. Over here, I have 6 graphs, one for each of these criteria, that shows the sensitivity of the solutions with respect to the priority that we are getting for that criteria. So for example, look over here, this cross point. It shows me that if the priority of demand is above 27%, the green line, product D, will be a better option than the red line, product A. Actual priority, almost 31%. That reads that if the priority of demand gets below 27%, then we'll have a rank reversal. Product A will be the preferred option, followed by product D. In this situation, it's not that important just because we're talking about a product mix. We are still with the same mix, A and D. Let's see what happens now with profit. Well, no matter what the priority of profit is, product D will always be better than product A. However, the third and fourth positions might change if the priority of profit, that currently is at 33%, goes above 50%. That would read that our model is pretty robust with respect to profit. Let's see, fit. For fit, that the current priority is 13%. If the priority gets above 17%, then we are going to have as a best option product A instead of D. Not very, very close, but it's cause of concern at that point. Similarly with process time. With process time, if the priority goes above 42%, they have actually more than one rank reversal. Well, however, process time's current priority is less than 10%. So there's no reason to be concerned with the process time because the rank reversal happens far away from the actual priority that we have. Similarly with the alignment, we have about 15% for the rank reversal, and the current priority is 11%. This is not extremely close, but again, I would keep an eye on the judgments that I had for alignment. And if I didn't enter the full of that matrix, because there are shortcuts, we can answer less questions than the required one. Well, if I didn't answer all the questions, then it's a good pairwise comparison matrix to go back and add information because it seems that it could be changed, the result in some cases. Timing system, current priority, less than 10%, actually closer to 6%. Rank reversal would happen at 30%. I will not even bother looking at that. I don't care what will happen if we change by 25% our priorities. It's far, far away from what we really want. Well, that was one perspective, how we solve the problem using AHP. But what about cases that the hierarchical structure is not enough to describe the system? What if we need to represent influences among the decision factors of a group or different groups? Well, in that case, we would change our model to an ANP model. The simplest possible ANP model that you could have is to group all the criteria together, all the alternatives together, as I have here, and create bidirectional flow, bidirectional connections. In that case, taking everything that you have already done and moving it to this new model, you will have to add information only about the profile of the products. So for the exam, I would ask you, what's the strongest feature of product A? And you could tell me it fits really, really well. And then it aligns very well with the company's goal and mission statement. However, it doesn't have so high demand, expected demand, and the profit is so and so. Definitely the process time and timing system are not good characteristics of this product. And on the other side, product D, I'm expecting to have very high demand and will bring a lot of profit. The alignment is not too bad. However, fit and timing system are pretty low for this product. And this way I would create the profiles for each of my products. Now, what would happen if instead of 4 products, I had 20 products to evaluate? When we have a lot of alternative solutions, or we want to be able to add, remove alternatives easily, we use ratings. When we rate the alternatives, instead of pairwise comparing them, well, we need to have an even better knowledge of the environment because you will not have the pairwise comparison process to help you extract the information. You have to be able to actually objectively evaluate each of your products by yourself. In that case, we need to also define scales for each bottom level criterion. For example, I would create like a type of scales for my intangible criteria like demand or fit. Make sure that you always have the same number of positive and negative options and one neutral. Or in cases that we have tangible information, I'll try to create ranges of scale and scales that will let me enter the values. Now, the scales is actually an art for itself because you have to define a scale in such a way that it helps you differentiate the products. So if I created for profit a scale that was from 0 to 20, and then 20 to 50, all my products will fit, almost all, except product B, will fit in the 0 to 20 range. So by putting everything in one bucket, I'm not helping myself to find the best option. I need buckets that are small enough to help me define which one is better than the other. And this is also an art because you have to balance out not too many buckets, not too little. Buckets that help you differentiate the solutions and select, and also not too specific that will lead you to have a large number of scale items, making your life difficult when you have to rate 20, 30, or 50 entries. So after you define your scales, the process is quite easy because you just need to go product by product, forgetting everything that you know about the rest of the products, and say, product A, what's the demand? I'm expecting average demand. What's the profit? It's within $10 and $20. What's the fit? Extremely good. I can't imagine better. Process time, it's in my second range, 101 to 150. Alignment, high. Timing system, high, which is not very good for us, but high it is. Similarly, for product B, I'll say expected demand, low. Profit, in the same range as before. I can't have them fit in different buckets, all of them, but I can at least make sure that the less than 10, that is a very low profit, and the more than 20, that is for this kind of products, a high profit, will go separately so I can actually help the decision. After entering all the judgments, by multiply the values that correspond to the scale items to the criteria weights that we had from the pairwise comparison matrix, we are going to get our final priorities. Now let's kind of try to compare the results that we are getting from these three methods. First of all, we have product A, D, as the top two, while in A and P, we see that product A is the one that is kind of getting the best option, followed by product C. Nothing about product D. I mean, it's actually the last in our result set. It's kind of weird, isn't it? And for the ratings, on the other hand, we have product D being the best option, followed by product A. Product B and C are together. I feel kind of hesitant with my results. AHP says A and D are the best products that I can have, pushing towards D. ANP says, hey, product A is the best that you can have, followed by product C. What is happening there? Am I doing something wrong? Shouldn't I be comparing the three methods? Did I mess up some of the pairwise comparisons? All possibilities, really. Well, the truth is that ANP shows how things really are, the current situation at your company. And right now, product A fits really well with what's happening in your company. And and the second one, and product D is not that good for the current setup that you have. Didn't I say what are my priorities for the criteria? Well, in AHP, I allowed you to tell me exactly what you wanted to happen. I forced the system to follow the priorities that I felt that should be the correct ones, saying that I want the products that I'll have to be very high in demand and profit, and then I care also about the fit. While in ANP, I am not inserting the priorities of the criteria. We are deducing them based on the profiles of the products. And what it says is, you know what, for the products that you have right now, it appears that you care about fit and alignment, you have product B in your production, so you didn't really care about demand or profit. And you also have product C. Product C doesn't have a good profit, but you're keeping it there. Current situation in your company is that you care a lot about fit. You are keeping products that are fitting together, and about alignment with the mission and the goals of the company. These are the criteria that appear to be important to you. On the other hand, we have in AHP what I desire to happen, what I would like to be the reality. So it depends on the way that you are trying to solve the problem and what is the truth behind your modeling process, what you're going to choose. If you're trying to find out, in case that my priorities are demand and profit and fit, blah, 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 that set of priorities, what should I do? Then AHP is better. If you want to evaluate what's the current situation in the company, then ANP is showing you a better perspective. And if you wanted to see what if scenarios, you would be welcome to remove products from the company and see at what point the criteria of the ANP that shows the current situation and the AHP align, which would show that with this product mix, I can actually have what I was dreaming of in AHP. But life is not that easy. We were informed that one of the factories providing us with materials, with material X, which is really needed to produce all our products, has been destroyed by a major fire. And now we expect to have shortage of this material for the next 4 months. I bet that it might sound familiar with quite a few of you, this shortage of materials. How am I going to use that, along with everything that I learned from my AHP models, to make valuable decisions on my production setup and mix? Well, I'll take the priorities for the products that I calculated, either from my ratings model or my AHP model, and then I'll add to that information about the units that I can produce, the units of material that I need to produce a unit of each of these products. And I will set up that way an optimization problem with a goal to maximize the performance score, so bring more value, not actually only profit as I would do in a classical linear programming problem, but value. Because over here in my priorities, I have the profit, but I have also all the other things that I want for my product set. So I will take all these values that are the priorities, the performance value, as I call it. I'll combine it with the requirements in materials that I have for each of these products. And I will set up my linear programming optimization model where the total used obviously must be less than the available amount that I have. I'm trying to maximize the added value. And I have also some balancing constraints in place because I want to make sure that things are getting in a specific way. Balance constraints. B's production should be more than 5% of the total. Production of C needs to be more than 5% of the total as well. D production needs to be less or equal than 40% of the total, and A less than 40% of the total. You would say why I'm setting up this kind of limitations. First of all, right now, we have not decided that we need to stop production of B and C. And we also have some orders in place. So I need some to keep being produced until management decides to cut off one of those products. At the same time, I know that A and D are bringing a lot of performance score in my model. So if I leave it unlimited, obviously I'll have an unbalanced production that goes through towards A and D. If I limit them to less than 40%, then I'll make sure that the remaining 20% will go towards B and C in a ratio that is related to the performance that they are getting us. So what did we do with this exam? We saw a family of methods that we can use to combine tangibles and intangibles. Each of these steps was backed up by mathematically sound solutions. I was combining tangibles and intangibles, but I was doing it using math and calculations. And more than that, based on the characteristics of the problem that I was solving, I was deciding about the correct method. And at the end, I combined my initial simulation results and my tangible from secondary and third-party applications with AHP and ANP, and I ended up getting all that information and using it in order to solve a final optimization problem based on the resource allocation in this case, but it could be a lot of different optimization problems. So you end up tailoring the representation of the problem to your needs, time at hand, and level of detail that you actually need for that specific decision that you're trying to make. And if you are interested in all these things that we talked about, you can use the Super Decision software in order to make a little bit faster the calculations and go more in deep in the analysis of the sensitivity. Or obviously, you can always fall back to Python or Excel if you need. You can find video tutorials on how to apply these methods on the Creative Decisions YouTube channel. And of course, if you are in the academia in this field, you're welcome to submit your research in our International Journal of the Analytical Hierarchy Process. You will find a lot of the published material, papers, videos, presentations on the Creative Decisions Foundation. And I think that was all on my side. I'll welcome questions at this point.
Thank you very much. That was great. I will now on to the Q&A, and I will tee these up in the order that they came in. There was 3 in a row by one person, so we'll ask those right at the end. But the first question is as follows. Do you have any examples where AHP is used to only prioritize decision factors, i.e. without drilling down to alternatives in the hierarchy model?
Excellent. That's a really nice question. Let me go back just a second when we were looking at our ratings model, or actually even a step before. The first thing that you do before even involving any alternatives is to pairwise compare your criteria. So yes, you can have the pairwise comparison of the criteria without even involving any alternatives and use that prioritization for any other optimization that you need. You could use, for example, the prioritization of the criteria in order to go to a second level and do either simulation or optimization on top of it. You can find some very good examples of prioritization and other decision models in the Super Decisions website. We are going to share also the links at the end. Next one, Bill?
Yes. Could you discuss the inverted calculation, how it was calculated?
That's a really interesting one. So I think that we are talking about the inverted calculation, for example, in the process time. We are actually seeing the initial values. We do 1 over the value in order to get the inverted, and then we normalize as usual. So I'll sum up the inverted values and divide each of the inverted values over the total. So bottom line, to invert them, 1 over the value for each of them.
Okay.
Bill?
Yes, ma'am. Can you explain alignment?
Yes.
And then so there's 3 questions altogether, just so you know, and they're all related to alignment. Can you explain alignment? What do you mean by high alignment? And okay, so that's it. So, and then the last one says, I know now what you mean by alignment. Thanks. So what is high alignment?
All right. So when we were talking about alignment, that is one of our intangible decision factors, we were really discussing about whether the products that we are producing are close to the strategic objectives of the company. For example, take a glass manufacturer that started by producing glass screens for the cars. Let's assume that product D is screen monitors. This is not very well aligned to their initial plans and how they were perceiving their company. However, it's low in alignment. While producing screens for the cars, the windows for the cars, it's high alignment, very close to their initial goals, but it might have an average demand nowadays. I hope that helps.
Okay.
Yeah.
Next one is, how can we apply AHP in survey research with a large sample size?
All right, that's an excellent question. We actually do a lot of group decision surveys. The first part would be to drill down and find the set of questions from the pairwise comparison matrix that you really need. If we are talking about big pairwise comparison matrices, we can, instead of taking all the values, limit ourselves to the judgments that belong to the first line, always above the diagonal, and the judgments that belong to the line above the diagonal. So in this case, with respect to demand, we would have product A versus B, C, and D, and then product B versus C, product C versus D. And although this doesn't look like a huge difference, if we are talking for a 10 by 10 matrix, we are really minimizing the number of questions that we need to ask. Now, the second, having a smaller set of pairwise comparisons is done. The second step would be to collect all the judgments with any tool that we are using, like Google Surveys or SurveyMonkey would work for this kind of purposes, and use the geometric mean to aggregate the values that correspond to each of the values. Having the aggregated results, you can make the calculations as usual. Now, there are two interesting problems with that. First of all, whether we are going to keep all the responses or only the ones that are above a level of consistency. And that could mean that we will have to do the calculations for each of the surveys before aggregating everything. So we can take out those that have very low consistency. And the second part is whether we are going to do any data analysis on top of the results. For example, we might want to find out the compatibility of our responders before merging the results, or make other kind of analysis on the responses before aggregating them. Does it answer to you?
Sounds good to me.
All right.
We have a couple more because we've got more time. So they're coming in. Are all pairwise comparisons essential? What about consistency? I could just compare A to B, B to C, and calculate how important A is to C. Does that? So,
yes, I think
okay, you got it.
Okay. Yeah, I think that is a little bit like we were discussing about the essential judgments. So we are discussing when we are talking about the pairwise comparisons being essential, we want a covering set for this table. However, if we have that covering set, and we can get it in a lot of different ways, we need just one judgment for each set, then we are good to go. Now, about the consistency, we need to calculate the consistency and make sure that the final result for each pairwise comparison matrix is less than 10%, or go back to the decision makers and ask them if they could consider to improve their results. Bill?
Next question is, can you please elaborate how the ANP was developed?
I think that's a little bit longer than what we have, but I can give you the general idea behind the ANP. AHP is structured hierarchically, not exactly like a tree, but put a tree in your mind just as an example. ANP is more like a network. So while Thomas Sati and the group of initial adopters of the AHP method was working on it, he realized that sometimes decision factors relate. Like, for example, when I'm buying a house, the price of the house relates to the taxes in that neighborhood, the safety of the neighborhood, and probably even the sales price of the neighboring houses. These factors that relate might belong to different groups. So I have to create a network of factors that connect and share influence. One factor influences other factors in the other groups and backwards. That is really the idea behind the ANP method. When you have a lot of factors and influence going from one to the other, you want to go towards the ANP setup. So really, we don't try to force the representation. If it's by itself naturally structured in a hierarchical view, we will follow that. If we see, while we are trying to do that, that there are influences that need to be represented, then we are going to move and upgrade our model to an ANP model.
All right.
Yes, Bill?
So next one is, can you please repeat how you define the values of the ratings scales?
Excellent. We didn't have much time to go into detail on the rating scales, but the truth is that each of these rating scales is a pairwise comparison matrix. So in order to get the values that I have here, I compared extremely high to high, extremely high to average, extremely high to below average, in the full set of the pairwise comparisons, calculated the priorities, and I ended up with a corresponding scale. Now, when we are talking about scales that we're using for tangibles, we might approximate each bucket with a specific value and use a direct entry in order to get the priorities there.
And the last one, can you kindly, there's one more after that. Can you kindly explain what to do when dealing with multiple inputs / expert judgments, say 100, talking about how to aggregate the inputs?
To be honest, what I would use would be some kind of library, for example, a Python library to do the aggregation, because it would be faster and easier, both than using Excel or any other tool. And I would use the geometric mean value by value. There are actually two different theories, and you can follow any of them. One theory says that you can aggregate the pairwise comparison, the eigenvectors that are the results of each pairwise comparison matrix. The other theory that I was suggesting says that you have to aggregate each judgment and then calculate the vector for each of the pairwise comparison matrices. I think that both have quite a few followers in the literature, and you can use both ways. Technically, it's actually easier if you are planning to take out the inconsistent entries, the people that didn't give consistent answers, to go to the priority vectors.
Okay. Can you, so how do you see the future of AHP and ANP, particularly when AI is dominating? Sorry,
I think that maybe you closed the... Can you repeat the...
Yeah. How do you see the future of AHP and ANP, particularly when AI is dominating?
Actually, I'll say that I have a dream, and that is combining AHP and ANP with artificial intelligence. I think that people have patterns when they pairwise compare judgments, and that's my personal opinion. It's kind of easy, given a few sets of pairwise comparisons, actually a few different decision-making models, to set up underneath an AI model that will extract the way that the decision maker is answering and can not replace, but actually help and facilitate the decision-making process by pre-entering values and giving you choices that are closer to what you feel correct.
Okay. Thank you. Is it better to ask pairwise comparison based on numbers, i.e., A is twice bigger than B, or based on words? A is moderate moderately better than B?
Well, it depends on the person that you are asking to enter the judgments. That's the honest truth. If you are asking me to do pairwise comparisons, I prefer to enter values, but there are a lot of people that react better to the verbal representation. So I think that you have to focus on your group of decision makers and decide based on their preference and their kind of what they are used to see. Lots of people are used to the Likert scale, so they react positively to the verbal scales. But other people that are used to work like in operations and data analytics that are used with numbers, they might find it easier and faster to enter the judgments as numbers.
Okay, and last one, we are almost on time. What do you think about fuzzy AHP and fuzzy ANP? Are they better models, or when is it better to use them?
Actually, this is a whole different discussion. Fuzzy AHP and fuzzy ANP are a whole chapter by themselves. They are very useful in specific circumstances, but probably not in this particular set of problems that we discussed today.
Wonderful. Well, that was great, and that was a lot of great feedback, a lot of great questions, and I thank everyone for their time today. Thanks for joining us, and on behalf of Creative Decision Foundations and Informs, I thank you for joining us. A recording of this webinar will be available very shortly on our YouTube channel. So thank you very much, and we appreciate your time today, and have a great rest of your afternoon or evening, wherever you are.
Thank you on my side too. It was great, and it was really nice to hear all these questions. Thank you.
I agree. Great feedback, everyone. Thank you very much for making this a very lively webinar. Have a wonderful afternoon and evening.